So we look at question 10. In a school, the ratio of the number of boys to the number of girls is 1:2. The pie chart show the different ways boys and girls go to the school. And they ask us what is the ratio of the number of boys who walk to the school to the number of girls who walk to the school. Okay, bearing in mind our total boys versus our total girls is 1:2. Alright, so if you take a look at this question, right, they give you in percentage. What I like to do is I'm just going to make it to 100% here. So I will put this one is 100%. So if I make it 100%, basically, right, it means I will need to times 100. So I'm making it to 100 is to 200. So if my boys is 100%, my girls in total here, everything, okay, I need to treat it as 200%. Then the tricky thing about this is if this is 100%, okay, this is 90 degree. 90 degree, right, is basically the same as a quarter, right? A quarter of 100% is how many percent? Everybody? 25, yes. So we know, right, okay, over here, right, this walking for the boys is 25%. For the girls, right, you cannot treat this as 20%. This is 20% if this whole thing is 100%. So, right, I will recommend you, right, to treat this as a fraction. Then you go and find how much percent is 200%. So basically what you do is 20% is 20 over 100. You simplify it further, is 2 over 10. You can continue to simplify further to get 1 over 5, but not an issue. You actually basically just take this 210 of that 200%. Then what happens is, opposite you can cancel the 0, and now we get 2 times 20, and that will give you 40%. So actually this is 40% out of the total of 200%. Then now it's fair to compare them already. Okay, boys who walk to school is a 25. And girls who walk to school is a 40. 25 is to 40, then you simplify it further, right? Divide by 5. You divide by 5. That's how you get 5 is to 8. Okay, so your answer is going to be option number 4. Okay. Question 12. Ivan had 30 fewer sweets than Peggy at first. So the fact that they say fewer, right, you need to draw model already, because fewer implies less than. Every time when you see anything that implies more than or less than, right, as long as it implies these two meaning, you all just draw model, okay? It will really help you all a lot. So Ivan gave some to Peggy. Then he was left with 28. Okay, so this is what happened. You're gonna cut a certain portion from Ivan. So I'm gonna cut, okay, this portion. So give, I'm gonna arrow it. And when it's give, right, I will use dash lines. So I know this is the extra part, okay, that come about. And then end up, right, left with a 28. So fill up that 28 here. Whatever you cut above here, do it the same down so that you can compare easily. So I want you to make sure if you cut the 28 here, below also cut it down. Now, right, we can fill up the units here. Peggy had 3 times as many as Ivan in the end. Whatever Ivan have in the end is a 1 unit, and whatever Peggy have in the end is a 3 unit, because 3 times. This part here is already given to Peggy. So can you tell me, Ivan, that 1 unit is equal to 28? Very good, because Ivan is left with 28 here. And Peggy left with 3 times, right, which is 3 units. So I'm going to put this whole thing is a 3 unit. So the fact that you know 1 unit is 28, then you can find 3 unit, right? You can take 28, multiply by 3, and then you have 84. So this whole thing here is a 84. So I take 84 minus 28 minus away 30. I will get 26. Okay, now 26 when I get here and here, right, I hope that you're able to tell they are actually the same thing, because this part here is same size as this. And if the same size means they are the same, then here, you just not give it to here, right? So basically, just imply that this and this is the same, this and this is the same, so that's why this and this are the same. 26, right, you just split into 2 equal portions, you will get a 13. Means this part is a 13, 13, 13. So how many sweets did Ivan give to Peggy? Ivan gave 13 to Peggy. So the answer is option number 1. Question 11. We have in the figure ABCD is a square. AD equals to DF. Then we have angle ADF is 58 degrees. Find BEF. So AD equals to DF. If they are equal, right, make sure you go and mark it out, the equal lines. Other than these two equal lines that you mark out, right, don't forget to also mark out the rest here, because square are all equal length. That's also very important. So that's the first thing you do. After that, okay, I want you to specifically look at angle DAF. Can you see that it is equals to angle DFA? Because this is an isosceles triangle. 180 degrees minus away the 58 degrees, and then you divide by 2. That's how you get 61 degrees, and I'm going to mark it out here, 61 degrees, 61 degrees. From here, right, okay, what else can you find out? Look at this diagonal line. It cut the square diagonally into half because it cut from the corner to a corner. So as long as it's from one corner to one corner, you all will know that this is how many degree, everybody? Yes, 45 degree, you're right. With this 45 degree, you got a 61 degree, and now they ask you to find BEF, right? Is going to be here. Can you see that? There is another triangle you can focus in here. 180 minus away, okay, this 45 degree, minus away this 61 degree. You will get the last angle right there, which is 74 degree. Okay. Then once the 74 degree, you zoom inside, isn't it vertically opposite angle are equal because there's two straight lines right here? So you will know the final answer is 74 degree. Okay, so question 13, we have figure 1 shows a rectangular paper. It is folded along dotted line AB to form figure 2. Which of the following statement is true? Okay, so if you were to look at the angles, according to vertically opposite angle, zoom inside, show you this and this, right? If it forms two straight lines, so you will know that, okay, this must be your C also. The fact that it is a rectangular paper, it means that this is a 90 degree. So if you zoom in here, fill up the 90 degree here also. Then now I want you to focus in this part here. C and D is how many degree? Yes, 90. Very good. Yes, because this plus this must add up 180 in the triangle, correct? So to get angle C and angle D is basically taking 180 minus away this 90 degree right here. Then you'll know, oh, together they must be 90. Yeah? This statement is a true. So statement B, the area of figure 1 is less than the area of figure 2. Okay, tell me it's correct or wrong. Statement B, everybody. Okay, y'all say wrong. Why y'all say wrong? So basically, I hope you can tell, when you unfold it back, right, this part here, you can imagine it's going to be something like this. Okay, this part here is going to be somewhere here, right? So when you fold it up that time, what happened is this part here, it will get overlapped here. So basically, whatever you are left with here, right, okay, is actually less than the original because of this portion. You know, that was being overlapped. So your figure 1, the area should actually be more. Yeah, so this one option is out. Okay, then statement C. Both figure 1 and 2 have at least one line of symmetry, at least. Line of symmetry means when there's a line, you can cut it into half and then you can fold it up nicely, right? So like, for example, this one, you can actually cut somewhere in the middle, right? Then you fold it up, right? It can be very nice, right? For this one, I don't know whether you can tell, but you basically can do something like in the middle also. Answer will be A and C, okay? Option number 3. Now question 14, so we have the figure is made up of 2 identical quarter circles and a square. The length of a square is 7 cm, and what is the perimeter of the figure using pi as 22 out of 7? We know length of the square are all the same, so this side here it must also be 7. And if this side here is a 7, tell me, what do you know about this quadrant and the 7? How is it linked together? 7 is the radius, exactly. If it's the radius, right, from the circumference to the center, it's also going to be 7. So once I fill everything, I want the perimeter of the figure, right? Okay, let's see the straight parts first. Here, 1, 2, 3, 4. I got 4 straight parts in the perimeter I need to find. So what I will do is I will take 7 times 4, I will get 28. Next part, I'm going to find here and here. So a quadrant, right, is 1/4 multiplied by pi multiplied by diameter. Diameter is the one that gives you the circumference. Okay? So tell me, if the radius is 7, what is the diameter? 7 plus 7, very good. So that is a 14. So we are going to get a 11, okay, for this portion. So this one, we know is also a 11. So together, we're going to plus 11 with 11 plus all the yellow parts, which is 28, and you will finally get the answer, which is 50, okay? Option number 2. Well, I can zoom in to show you. So basically, okay, opposite numbers, right, you can divide. So what happened is you ask yourself 7 and 14, right? Can you like divide them with a common number? And you will know that 7 and 14, they both can be divided by 7. 14 divided by 7, you will get a 2. 7 divided by 7, you get a 1. These two diagonal numbers also can divide. So I will divide by 2. 22 divided by 2, I will get 11. 4 divided by 2, I get a 2. Last but not least, like this and this is also considered diagonal numbers. This is a fraction and this is actually 2 over 1. So actually this and this I also can continue to divide by 2. So divide by 2 I get 1, divide by 2 I get 1. So end up right here I just have 1 times 11 times 1. Okay, so I get 11. So we have Mrs. Lim bought some pears and oranges and packed them into 2 bags. 3 out of 4 of the fruits were in bag A and the rest in bag B. So we understand this 3 out of 4, what you represent first, okay? So numerator here 3, denominator here 4. 4 unit, your denominator is your total fruits, of which out of the 4 units, your 3 units are the one that are inside bag A. So remember, I always told you what, right? One fraction is actually equivalent to one ratio. So you can actually come up with a ratio with this fraction. Fruits in bag A, which is 3. Then I can find out one more thing other than my total is 4. Who can tell me what do I fill up here? You tell me 1. Very good. Yes, 4 minus 3 is a 1. But what is that thing here that I'm trying to find out? Bag B. Very good. The fruits in bag B. The rest are in bag B, right? We have 9 of the fruits in bag A were pears. Okay, what does it mean? It means your 9 units right here, they refer to the fruits in bag A. And all of the fruits in bag A here, 4 are pears. So the next ratio you can come up with, right, is your fruits in bag A, which is total of 9 units, and of which, right, your pears in bag A, right, is 4. So at this point in time, right, I hope that you're able to tell this here is your repeated item identity. Your fruits in bag A, right? Earlier on it was a 3, but now it's a 9. So it's your job to make it the same. Okay, so you need to multiply by 3 first, which will get 9 is to 3 is to 12. Half of the fruits bought were oranges. So your keyword here, fruits that you buy, equivalent to that 2 units right there, of which 1 of it are your oranges. It means, right, your total fruits that you buy is 2, of which, right, 1 are oranges. So I'm going to write oranges will be 1. Tell me, what is one more thing I can find out here? My pears. Very good. Pears. Okay, 2 minus 1 is a 1. Okay, in fact, you realize, just now I could have also found out more things here. I can take my fruits minus my pears. I will get my oranges. Your fruits bought here, it must be your total fruits here as well. It should be the same thing that they're referring to. So to make it to a 12 from a 2 is going to multiply by 6. You'll get a 12 is to 6 is to 6. So these two ratios I link up already. I also make this 9 and 9 the same already. So I also link these two up already. So means I link all the ratio here up already. What fraction of the fruits in bag B were pears? They say fruits in bag B. That means this is your denominator they're referring, because after the keyword of the, right, this keyword here is always your denominator, and the pears they're referring to will be in your numerator. Your fruits in bag B, tell me, what's your denominator? What number that you take out from here? Bag B here, fruits in bag B is a 3. So your denominator is a 3. You want pears inside bag B only. I want you to look at the pears in total, which is 6 units, of which, right, in bag A, 4 units. So tell me how many pears are there in bag B? Yes, it's 2 units. 6 minus away the one inside the bag A, I will get the one in my bag B is 2. So my numerator is a 2, right? So my final answer is 2 over 3, which is option number 4. Use all the digits 6, 5, 0, 8 to form the greatest multiple of 5. Every time is multiple of 5, right? Confirm the ones place, right, must end with a 0 or a 5. Why? Because your 5 times table, 5, 10, 15, 20, 25, 30. You see a pattern. It's either 5 or 0 or 5 or 0 or 5 or 0. If you want the greatest, confirm you'll put the greatest number in front. Okay, out of which, right, 6, 5, 0, 8. Of course, 8 is the greatest. So after I do the 8, the next greatest will be a 6, right? So I will put the 6 there. Then I left with a 0, 5, which I can put in my ones place. But since I want the greatest, then I will choose the next greater number to put, which is a 5. Okay, then lastly I put a 0. Jessie had a total of 30 20-cent and 10-cent coins. She exchanged all her 10-cent coins for 20-cent coins and had a total of 17 20-cent coins after the exchange. How many 10-cent coins did she have at first? Find out things that you can find out first. She has 17 20-cent coins. It means you can first find your total value of your 17 20-cent coins. Your total value is taking 17 multiplied by 20 cents, okay, which you will get 340 cents. You have the total number of coins, which is 30 originally. So I call it total quantity. You exchange the 10 cent to 20 cent coin, end up you got this amount. This is the total value. When she exchanged the 10 cent for 20 cent coin, right, will this total value change or not? No, right? Else you are either making a loss or making a gain, right? Somebody. So you want to make sure the total value will remain the same, which is 340 cents. Yes. So if the total value stay the same, it's going to be 340 cents originally as well. So basically, your two main clues are total quantity and total value. Two totals, no comparison. What is the method? Assumption. If not, guess and check. Also can. Assumption question, right? We always assume the opposite first. If they ask for 10 cent coins, you need to assume all are what? 20 cent, yes. Now, if you assume all are 20 cent, right, you got 30 of them. So you are going to take 30 multiplied by 20 cent. Your total value, right? Okay, 3 times 2 is a 6. Then you add the 0, 0. Your total value is a 600 cents. But we are at 340 cents. The next step is to find your total difference, which I will take 600 cents minus away 340 cents. I will get 260 cents. Next one is finding your each difference, because your small difference will add up to become your total difference. Between the 20 cent and 10 cent, what is each difference? Okay, so 20 cent, you minus 10 cent. Every time you change a 20 cent to become 10 cent, right, the difference is a 10 cent. And this small difference of 10 cents, it will slowly build up to the total difference of 260 cents, which we need to match up to. So your last step is taking 260 divided by 10, you will get 26. Every time you do this step, right, this 26, you will straight away find the thing they're asking you. So how do you check? If you have 26 10 cents, that means it's 26 times 10 cents. Currently, you are at 260 cents. You see, out of the 30, right, 26 are your 10 cents. So how many 20 cents are there? Very good, 4, huh? 30 minus 26 is a 4. So you're going to double check by taking 4 times 20 cents. You are going to get a 80 cents. So now, let's find the total value. 260 cents plus the 80 cents. Do you get back 340 cents, which we are supposed to get just now? And if it's a yes, that means you're on the right track. So your answer is going to be 26, okay? So we have a rhombus ABCD on a square grid. Using the line RS, draw a square such that you have the same perimeter as ABCD. RS is here, and you're supposed to draw something that has the same perimeter as ABCD, which is this one. For a square, you need the 90 degree. What I will tell you all is you will place your ruler like here, or your set square. You place it here, right? The one that will form 90 degree, right, is this line. And then, if you use pencil, you're going to most probably get a line that you can get out from your set square or your ruler. Then how are we going to determine how long it is, right? Okay, let's look at one line here. 1, 2, 1, 2, 3. So look at this, 1, 2, 1, 2, 3. You realize, this line actually same as this line. So we're going to follow the same pattern for this. So I'm going to go 1, 2, 3, 1, 2. Actually by right end here. Alright, so next one, we're going to do the same way. 1, 2, 3, 1, 2. So you go here. And we're going to join up the last one. Okay, there's a certain technique to label also. Okay, don't anyhow label. The PQRS, right, it must go in a certain direction. Either the clockwise or anti-clockwise. only can follow one direction. If you see your RS is here, P first, then Q, you go this way, right? Then you go this way, you go this way, okay? In this case, I'm going clockwise direction. Okay, part B. So what fraction of the area of the rhombus ABCD is the area of square PQRS? Now they're comparing the area. I'm going to look at the rhombus first, which I will split into two triangles, here and here. So if I were to look at this triangle, right, our base is 1, 2, 3, 4. Half times 4 times, if this is my base, 1, 2, 3, 4, my height is going to be here, 1, 2, 3, 90 degrees. So it's half times 4 times 3, give me my top triangle. Half times 4, right, I will get a 2. 2 times 3, I will get a 6. So basically, this part here is a 6. And you will realize this triangle is the same as this triangle because the base is 1, 2, 3, 4, the height is also 1, 2, 3. So to find out the area of this rhombus, right, since it's two triangles, 6 times 2, it will be a 12. So now I'm going to look at my square. Now my square I cannot find directly. This one is not a vertical line like this or not a horizontal line like this. Okay, it's slanted. Slanted, I cannot treat it like 1, 2, 3. No such thing. Okay. So what you're going to do, right, you're going to find it indirectly by arrange it into a big proper square and then I minus the triangle. So I'll make a bigger square, okay, with the horizontal and vertical part. Then I will take this big square, minus away this triangle, this triangle, this triangle, this triangle. I will get my middle square. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 by 5, right? Okay, is a 25. Now I'm going to find this one. It is half multiplied by 1, 2, 3 multiplied by 1, 2. It's going to be a 3. This one is the same. Why? Because base is 2. The height is 1, 2, 3. 1, 2, 3. So you know that these two triangles are the same. 1, 2, 1, 2, 3. Oh, this one is also the same triangle. 1, 2, 1, 2, 3, right? So it's also the same triangle. So since I got 1, 2, 3, 4 of these triangles, right, I can just take 3 times 4. All these 4 triangles add up to a 12. So last but not least, I will take the total area of this big square, 25, minus the 4 triangle here, which is a 12. I will get a 13. And finally, what fraction of the area of rhombus is the area of the square PQRS after the keyword of the, this one is your denominator. This one is your numerator. Okay, the one in the end is your numerator. So you sub in the numbers carefully. Denominator is your rhombus ABCD, which we have gotten 12 here. And your square PQRS, 13 here. So our fraction is 13 over 12. Mixed number is a 1 whole 1 over 12. That's your answer. Question 25. In 1 minute, machine A can pack 5 boxes of cookies. Machine B can pack 2 boxes of cookies. For rate, right? Always write down whatever they tell you. Okay, so what is happening is both machines started packing at 12:50 a.m. At what time will both machines pack 175 boxes of cookies in total? Leave your answer in 24-hour clock. The fact that both machines are packing at the same time, it means, right, you need to take your A and your B plus together to find out in 1 minute how many they can pack together. So, right, you take 5 plus 2, they can pack 7 boxes in 1 minute together. So, to find out number of minutes, you will take 175 divided by 7, which will get a 25. We need to leave our answer in 24-hour clock, okay? And we start at 12:50 a.m. So, 12:50 a.m., I'm going to split my 25 minutes, right, into 10 minutes first. I will get 1 a.m. So, if I go by 10 minutes, 25 minus 10, right, I still left with 15 minutes. I still need to continue. Now, continue, 15 minutes. Then I will get 1.15 a.m. right at the moment. This is your 12-hour clock, okay? If you forget what is your 12-hour clock and 24-hour clock, okay, let me show you. 12-hour clock, right, you must have the decimal point and you must write the AM or PM. If it's 24-hour clock, right, you do not write the AM or PM and you must have 4 digits. If it's 1 a.m., it's 0100. So just now our answer was 1.15 a.m., right? 1.15 a.m. You need to write your answer as 0115.